So, once again, this is called Engage New York. You can find all of this information, the packets that I've given you, online. Okay, if you type in www.engageny.com or .org or whatever it is, go to Google, you can find it. This is where we're at. And this is the key portion to what we're doing right now, because I'll have videos, but there are people who are better than me, and I don't like to admit that, but who have been working with Eureka Math throughout the entire year instead of starting right now. So they have a little bit of a better grasp on it. We are doing grade 7 module 3. Look at your packet right now, okay? Notice how in the top right-hand corner it says 7, there's a dot and a 3. That means grade 7 module 3. But look at the top of the paper. See how it says lesson 1? That's how you know where you're at. If you want to watch a video of this, besides mine, that might be a little bit more cohesive, because the video now, I'm not doing so much stuff up on the board as much as it's now getting projected up on the board, because you guys have it in front of you. So I'm going to have to do very little writing down. Everybody with me still? So if you want to watch a video that's not just me talking and a blank board, you should probably go to YouTube, type in grade 7 module 3 lesson 1 Engage New York. The key, and maybe you should write this at the top of your papers, is this is Engage New York. Okay. So, today we are going to do a little bit more togetherness. Usually, you're going to say, hey, get started, and I'm going to let you start going, because you're going to have about 10 minutes to do all these things, and then I'm going to go over it. Again, listen, and it's on the video now, so your parents can hear it too. Your grades will now predominantly be classwork and homework. Does everybody hear that? So you must work in class. If you decide, nope, I'm going to sit back and take a back seat, you will not pass. It's like Gandalf in Lord of the Rings. Man, I'm a nerd. You shall not pass. Yes, correct. Okay, good. I'm a nerd. I'm a proud nerd. So, letter A says write an expression. Let's go back a little bit. What do we know an expression is? I should see more hands on this. Kendall.
An expression is something without an equal sign.
Good. It's a mathematical sentence with numbers or variables or mathematical operations that does not have an equal sign. Very good. So none of our problems are going to have an equal sign. So write an expression using T, which represent the number of triangles, and Q represent the number of quadrilaterals. Write an expression using those to find the total number of sides in your envelope. And then explain what the terms in your expression mean. So, how many sides are there on a triangle? I should see everybody's hand. This is not one that we shouldn't know. Mr. Ewing, how many sides are there on a triangle? 3. So if there's one triangle, one T, how many sides are there? 3. What if there's 2 triangles? How many sides are there? 6. What if there's 3 triangles? How many sides on the triangles are there? 9. Is there something that with a variable, T being the number of triangles? So we know that T equals the number of triangles. What expression can I write if I don't know how many triangles I have to find the number of sides? What can I write? Go ahead.
T times 3.
Perfect. So, Owen has said T times 3. Well, in math, when we're showing multiplication, we show it with the number in front of the variable. That's called the coefficient, right? We've done this already. This means multiplication. No matter how many triangles I have, if we have 27 triangles, well, I can do 3 times 27 to figure out how many sides we have, right? But it says the total number of sides for triangles and what? Quadrilaterals. I know you were yawning. So quadrilaterals. And it says Q is the number of quadrilaterals. Everybody still with me? Okay. How many sides are there on quadrilaterals, Cece? I can't see that well. Words. 4. There are 4 sides of a quadrilateral. So here we go again. Jojo, if there's one quadrilateral, how many sides do we have? 4. If there's 2 quadrilaterals, how many sides do we have, Renee? If there's 2 quadrilaterals, how many sides do we have? 8. Is there an expression that I can write for the number of quadrilaterals to figure out the sides if we don't know the number of quadrilaterals? Layton?
4Q.
Very good. 4Q. But let's read the question again. For this exercise, each envelope contains the number of triangles and the number of quadrilaterals. Where is it? There it is. Shoot! Write an expression using T and Q that represents the total number of sides in your envelope. Not the total sides of triangles, not the total sides of quadrilaterals, but the total. What do we need to do with these 2 expressions, Maddie? Add them. This expression, now listen, I know we're starting something new. If you do not have something in your hand writing this down, you will not pass math anymore. So pick up your pencil and copy.
Just so you know how to gauge. Wow.
I was told that we have 2 minutes left with this. But today, again, here's some of our hiccups, okay? So,
We're having to figure out.
yeah, we're figuring out, so you're going to hear Mrs. Armstrong and I talking about time a lot because we're supposed to have a time limit on this. But that's for us. You're going to hear me go, wow. You're going to hear me express some things. Just like you might be frustrated, I'm going to get frustrated throughout it, but you know what? It's going to be awesome when we're done. So, what is this saying? This is saying we can figure out the total number of sides for any one of your envelopes. Because maybe Layton's and Taylor's has 7 triangles and 2 quadrilaterals. We can substitute that in and figure it out. Right? Okay. Letter B. You and your partner have the same number of triangles and quadrilaterals in your envelopes. So now you're talking across the table. Write an expression that represents the total number of sides you and your partner have. So let's just talk to this table here. Ada, how many triangles do you guys have? How many triangles do you guys have?
4.
So you have the same exact amount of triangles. How many quadrilaterals? How many quadrilaterals?
2.
So you guys have the same number. How can I figure out the total number of sides for those 2 groups? What could I do with this expression? We're only dealing with this expression. What could I do with that to figure it out?
So you could probably add the ones that are like the like terms together.
I love that. So, Layton, here's what I hear you saying. So one group has 3t plus 4q, and then you're saying add them to the other group, which also has 3t plus 4q. That's good. And then you said something else. You said like terms. What do you mean like terms?
Like the variables and
Okay, so tell me.
3t plus 3t.
Oh, because we have to include the sign in front. Good.
And then
What is that?
positive 4q, positive 4q.
What is 3t plus 3t?
Oh, 6, sorry.
6 t's. Okay. And then you told me positive 4q and positive 4q, which gives me?
8q.
What kind of 8q?
Positive.
Oh, so that's one way to show. That was awesome, Layton. That's one way to show the total number of triangles for these 2. Is there another way that I could have done that? Instead of adding them up, what could I have done?
Think back to our distributive property. Okay, think back to what we learned about distributive property.
Owen?
Take
So let's start with our original expression, 3t plus 4q. What could I do to that to figure out the total number here? Instead of adding, what could I do?
multiply
Multiply what?
3t and 4q.
Oh, so both of them. So that means I'm going to put them in parentheses. And what am I going to multiply it by? How many groups were there?
2.
So I can multiply that by 2. And that would give me the same exact expression when I simplified it. Okay, so there are multiple ways to do this.
So I'm gonna compliment, I'm looking around and I'm seeing a lot of people write information down for part B. You might not have gotten to it when we were working independently, but we're reviewing it now and you're following along and that's what the expectation is. So keep it up.
So listen, part of your grade is going to be a notebook check. I will be checking to make sure that you have this stuff down. This is very important to me. So if I have all of this work, you should have all of this work. It's not a, hey, I'm going to just pick and choose what I write down. Nope. Okay, letter C says, write an expression that represents the total number of sides in the room. Well, what can we do to figure out the total number of sides in this room? Could we figure out how much the total sides for these two groups were? What did we do? Layton? We either added them up or we multiplied them. Okay, so what can we do to figure out the total number of sides? If I multiplied my expression by 2 when there was 2 groups, what could we do to figure out the total number?
Multiply it by the number of groups.
Multiply it by the number of groups. So that's what I would write here first. I would say, we will multiply our expression by the total number of groups. From here, what was our original expression that we're going to be using, Ella?
Wait, 3t backwards?
Yeah,
Oh, 30t plus 14.
good. Because this told me how many sides you had in your envelope, right? 3 was the number of sides of a triangle times the number of triangles. 4 was the sides of a quadrilateral times the quadrilateral. Well, let's do this. So this was a group, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What do I need to do now for letter C to figure out the total number of sides for this entire class? Lauren.
Multiply 11 by 3 and 11 by 4.
So I'm going to put this in parentheses, and I'm going to multiply this whole thing by 11. What is this property called? What is this property called? Jojo?
Distributed.
Very good, Jojo. This is the distributive property. Remember, when we're distributing, we are multiplying. Could we have written it like this, 3t plus 4q, 3t plus 4q, 11 times? Yeah, is that what we, I mean, do you think that's the best mathematical way to do that? No, this is why we have the distributive property. Everybody still with me? Okay. Letter D. And guys, like, look, I want you to notice that I've got notes up here too. Like, these are things that I've looked at, that I've made to try to make it as much sense as possible for myself. Okay? So, I'm not going into this blind either. So if you see me for the first couple days walking around with papers, you're darn tootin'. I put a lot of work into this. You're darn tootin' that I'm doing that. Okay. So we are now on letter D. How much time am I over right now?
Okay,
Well, I'm just trying to get a feel of 10 minutes?
about 5 minutes.
About 5 minutes? Okay. So now we are on letter D. Letter D says use the given values of T and Q and your expression from part A. So our expression, this is why we have to have everything written down. Here's our expression from part A. To determine the number of sides that should be found in your envelope. Everybody should be able to figure out what we're substituting in for T and Q based off of your own. I'm going to give you 15 seconds. Talk to your partners, figure out what you think we need to substitute in to our expression to figure out the sides for your envelope. So talk it over. What do you think we're substituting in for T and Q to find the total number of sides? Go, talk it over.
Well, it says minus Q and your expression for A, determine the sides.
Probably done.
And time. Whew. Steph, if T is the number of triangles, how many triangles did you have? What? 4. So what do you think T is going to be? Oh, so Steph told me that T is 4 because we already said, notice how I labeled my variable. I think that's very important. T equals the number of triangles. So now Steph's told me there's 4. What do you think we're going to substitute in for Q? Addie? 2, because why? Because there's 2 quadrilaterals. So now we're going to try to figure out, by simplifying, how many sides we have. We already wrote this. 3T plus 4Q. Guess where this 4 goes? I heard it. Somebody put your hand up. Where does the 4 go? Oh, come on. Brooklyn. 4 doesn't replace the 3. What is this? T is 4. Go ahead, Addie. Oh, so it's getting substituted in for T. So remember, when we have a coefficient up against the variable, that means multiplication. So this is saying 3 multiplied by 4. Okay, Brooklyn, I know I'm going to pick on you a little bit. So if T is getting replaced by 4, what replaces, or what does 2 take the place of? Q. So now I have 4 multiplied by 2. Notice that I put parentheses where those variables were. Everybody with me? Okay, can we keep simplifying this? Go, you have 15 seconds. Simplify. That means get me an answer.
That's 12. That's 8. 12 plus 8. Do you understand it, Kendall?
No.
What's 3 times 4 times 3?
12.
Okay. Plus, it's 4 times 8. Okay, it's 12 plus 8.
So what?
12 plus 8.
I'm doing this. This is not gonna. We don't need to do this in real life. Oh, let's find what T equals for the amount of triangles I have. What envelope?
Something.
Okay, so what do I need to do, Jackson, to start to simplify this, buddy? Right here. Okay. Elizabeth, what do I need to do here to start to simplify this?
12 plus 8.
Where did you get 12 and 8?
I multiplied 3 and 4.
Oh, okay, so this is 12 plus, you're saying this is 8, correct? So now we simplify 12 plus 8. Jackson, I'm coming back to you, bud. What's 12 plus 8?
20.
20. So there are 20. And if I just put 20, does that help me?
No.
Because it was a word problem. What should we put with this? Brooklyn. 20 total sides. So each envelope had 20 total sides in the envelope. Everybody with me? So with this, could we go down to E and F? So E says, use the same values for T and Q and explain. Let me try this again. Use the same values for T and Q and your expression from part B to determine the number of sides that should be contained in your envelope and your partner's envelope. So let's say every group is matched up with somebody. So that means Cece and Addie would be matched up with somebody. That means each group is going to be paired. How can we figure out how many total sides there are if we are matched up with a group? So, we've already figured out part of it. We've already said that if we've got another group, we can use 2 multiplied by 3t plus 4q. Does everybody agree? So, with E, we could say still 2 multiplied by 3t plus 4q. Except this time, do we know what t and q are? Oh, so we're really saying 2 multiplied 3 times 4 plus 4 times 2. Oh, well, we need to simplify. So that's 2 multiplied by 12 plus 2 multiplied by 8. Well, I can still simplify. That's really 2 multiplied by 20. Shoo! So between 2 groups, how many sides do I have? Between 2 groups, how many sides do I have? Taylor? Between 1 group we have 20. 40 because it's 2 multiplied by 20. So 40 total sides between 2 groups. Make sure you have that written down for letter E. Okay. Now, I want you to do letter F as a group. Come up with some expression that's going to help me do letter F. I'm going to read it, you're going to follow along, so I want you to read this silently in your head while I read it out loud. Use the same values for T and Q and your expression from part C. The expression from part C to determine the number of sides that should be contained in all of our envelopes. So I want you to set up an expression and simplify it to figure out the total of sides in all of our envelopes. So go ahead and start talking about that.
Okay, so 3 t plus 4 is whatever C was. So that's 11 3t. I'm confused. Alright, so use the same value T and Q and your expression from part C. That's 11 times 3 and 11 times 4. I put so I just put an 11 in front of it. No? Yeah.
I'm hearing some really good conversations. Keep going, guys. When you do it. Although you're not here. Okay, we're gonna give you about 30 more seconds to talk. I thought I was talking about letter F, okay?
Okay, and then we don't write these. That's it. Maybe we should have. That's T and that's Q.
So did you substitute in for T and Q? So I'm wondering if you substituted in for T and Q to find the total number of sides, because that's what the question is about, right? So what are our numbers for T and Q? Okay, so do you have to substitute in, which means take the number that represents T, take the number that represents Q, and put it into your expression. What do you think?
3 times 4.
To find the total, can you have the variable present? So are you going to have to substitute in? Yes.
So we want to substitute
You-
12.
You would. Yeah.
Oh.
Yeah. All right. So I've heard some fabulous conversations for letter F. I heard some really mathematical conversations for letter F. You guys, you did a nice job. And I also saw, which is the whole idea, people going back to your examples. Fabulous. Nice job doing that, okay? So letter F says, use the same values for T and Q in your expression from part C to determine the number of sides that should be contained in all of the envelopes combined. Okay? So, I saw lots of people going back to part C, and you use this expression. Fabulous. Okay? That's what it told us to do. So someone share with us what you came up with for your information for letter F. Yeah, I'm just not saying answer. I just want you to explain what you did. So we're not gonna write it out. Go ahead.
Okay,
T.
so I did 11, and then I did and then I did 3T plus 4Q.
So we use the expression from part C, our total number of envelopes, our sides per triangle, plus our sides per quadrilateral. Okay, what's next?
So then you do 11, and then the parentheses, and then 3, and then parentheses 4, and then plus 4, and parentheses 2.
Hey T, can I ask you a question?
Yeah.
Why did you substitute in 4 and 2?
Because there's 2 of
Oh, so T and Q are the total number of that figure in your envelope. Okay.
And I saw quite a few people put down this very similar information, okay? So keep going.
So then you do 11, well, yeah, that's 11. But 3 times 4 equals 12, and then plus 4 times 2 equals 8. And then 11 times, and then 12 plus 8 equals 20. And then 11 times 20 equals 220. That's fine.
So we have 220. What I hear you saying is that we have 220 total sides in our class. Okay. Nicely done. How many of you came up with this information for letter F? There's more than that. Come on, people. Okay. Nicely done. And the whole key to letter F is that we have to substitute the number of triangles and the number of quadrilaterals in for the variable. So, nice job. Okay.
So, example 1. On that same page, you should see example 1. There is a part A, a part B, and a part C.
No.
It says,
So we're right here, down where it says example 1. You can go down the screen.
rewrite 5x plus 3x and 5x minus 3x by combining like terms. Do not worry about write the original expressions and expand. Nope, all I want you to do is rewrite 5x plus 3x by combining like terms, and rewrite 5x minus 3x by combining like terms. So guess what you're doing? You're combining like terms for part A. You're going to do the same thing for B. You're going to do the same thing for C. Go.
You can work with your team.
Yep.
Work with your partner. Go ahead.
And then we would add those 10.
So after this, we'll just go right now.
I think that's what we do.
Could this be, would this be wait, we can still.
Yeah, but like,
Simplify
I think that's what you do, but I don't know how it goes.
5 is plus big.
Oh, no, it's not.
Did you talk to your partner?
So we should be combining like terms. This part is a review. You guys have combined like terms before. Talk it over, see what you guys are doing.
Yes.
So what I think we're gonna do, like, okay, so I wrote it down, but I didn't think it was right.
Okay.
So 5x plus 3x equals 8x, and 5 minus 5x minus 3x equals 2x. And we add those, and it equals 10x.
You don't have to add those, you're just working on the expressions and finding what you did. So the top part that you did is great. Okay, did you talk with Lauren and Kendall? Okay.
Okay. We literally just
So we're doing all of example 1. There's A, B, and C on part example 1.
There's a letter C on the next page.
Okay, I think that's just what you do.
Do we have to do beats?
Yes, and C.
Okay, so most of you felt pretty good about this. 5x's plus 3x. Now, I'm not going to spend too much time on it. It says expand it to addition form. Well, what that means is this is going to be x plus x plus x plus x plus x. That's 5x's. Does everybody understand that? Mm-hmm. Plus, well, what would I do for 3x's? I'd write 5x's?
Oh, no, 3x.
Well, I put x plus x plus x. Could we do this for every single problem? Sure. Do you want to?
No.
No, because if we have 5 and 3, that's 8. So this is 8 what? X. We know that we add the coefficients, we keep the variable. So in this case, this would really be x, x, x.
Mr. H, can I see Joe Vice?
Sure.
Thank you.
X minus 3x's. Well, if we're subtracting, we're taking these away, we're taking these away, we're taking these away. How many x's am I left over with? Oh. But remember, we do the operation with the coefficients. 5 minus 3 is 2. We keep the variable. You need to have those two. Okay. Sum of. What does sum mean? Blaze. Yeah, it's the answer of an addition problem. So sum of 2x plus 1 plus 5x. So when we do this, there's 2x's here. There's positive 5x's here. 2x plus 5x is 7x's. Is the positive 1 a coefficient? No, because it doesn't have a variable, so it's called a constant. So we just bring it down. We cannot combine coefficients with our constants. That's part B. You should have that. Okay, part C. The sum of negative. Oh, that marker's not good at all. Get away. Oh, close. Negative 3a plus 2. Sum, Blaze told us, was addition. 5a minus 3. So when I do this now, I can start circling my like terms. We've got negative 3a's, positive 5a's. Negative 3 plus 5 is positive 2. My constants are like terms. Positive 2 minus 3 is negative 1. There we go. Nose trumpets, if you got all A, B, and C correct. Excellent. So, here's what you need to do. You're going to flip a bunch of pages. We're not doing example 2. We're not doing an exit ticket today. We spent a lot of time on the warm-up. Go to the last 2 pages. So your last page. At the top it says lesson summary, and then it says problem set. So you should be at the page right now that looks like this, where it says problem set. Everybody with me? You are not doing this all. You are only doing 7 problems. Circle these now. You are doing from the problem. This is the homework. Now listen, because you need to understand this very clearly. There is no time built in for us to go over the homework. I'm going to be collecting homework from now on. Sometimes it might be once a week. Sometimes it might be every day. You will not know that. So, that means do your homework on something that you're going to be able to turn in that you do not need. Does everybody understand that? So don't try to fit all of your work on this page. Yes? I'm not telling you that I'm going to collect this homework tomorrow.
Which means if you're not looking at Mr. H, you don't know what he's doing.
Okay? So I'm not telling you that I'm going to collect this and grade it tomorrow.
Okay, good. Just kidding.
Oh. So, homework. This is from where it says problem set. Numbers 1, 2, 3, 10, 11, 12, and 17. I need you to read the directions because it does say simplify, I think. It says, wait.
No.
It says verify the equivalence. We're combining like terms. So I want you to combine like terms, but then it says evaluate, which means substitute in. So look at number 1. It says 3a plus 5a. Right now, off the top of your head, we should know what 3a plus 5a is. What is it? 8a. 3 plus 5 is 8. So it's 8a. That's part of your answer. But then what does it say? Evaluate given the value. So what will we have to do? What, Ada? substitute in the place of A, you should have what? 2, because that's what it says A is. So you're simplifying and substituting in. Listen again. You are simplifying by combining like terms and substituting in.
Do we want to do number 1?
I would love to do number 1 with you. You should write this down right now.
So number 1 is your example, and listen, you guys did a really great job going back to the examples in the warm-up. This information is yours to help you do the work. So right now, we're doing number 1 for your homework. You should be writing it down so you know what to do.
Okay, so 3A plus 5A. If I needed to, could I write A plus A plus A plus 1, 2, 3, 4, 5? Sure, I could, but you can look at this and say, okay, if I have 3 A's and I add 5 more A's, that gives me 8A. That's one part of it. But if you look at the top of that problem set, it tells me A equals 2, B equals what? 5, and C equals what? 3. Negative 3?
Yeah.
So now I want to substitute it in. So I'm going to say 8A, 8A, and that gives me 16. I need both. Does everybody understand that? I need to see both. So if you haven't done so, if you don't have a separate piece of paper out doing this, because you're not going to rip this out of your packet and turn it in, that's what I was trying to get to when I said, hey, you need to make sure that you're able to turn this in, so you do it on a separate piece of paper. This is what I should see for number 1.
So, everybody freeze for just a second, okay? Put down pencils and listen to what we're gonna tell you. So when I say freeze, I shouldn't hear paper, shouldn't hear pencils. From now on, your homework will be done on a sheet of notebook paper that you can turn in. You are going to have the problem sets in these packets. However, you don't turn,
The packet
like Mr. H said, rip it off and turn it in, because these are your notes. These are your references. These are the things you're going to study from. We don't want to take it from you so that you have it.
Please.
So, your homework from this point on will be turned in on notebook paper. Okay?
So you should get out notebook paper and copy down number 1. That only leaves you with 6 other problems. Good job today.